Hi guys, welcome back to the Ardor server. So a couple of weeks ago, my personal laptop just stopped booting. And I kind of was actually expecting this to happen sooner or later because my boot drive, which was an M.2 SSD, which is the one that you see right here, was already showing a lot of errors while I was actually in the middle using it. And one day I applied some updates, was running Fedora Linux workstation on it, and there were some updates. I applied the updates, rebooted, and after the reboot it could not mount any of the file systems. And so this has completely failed now. Well, when I say completely fail, you can still actually access some of the storage on this SSD, but this has always given me a lot of problems. So this is an Intel P600 series SSD. I bought it many years ago and it was very cheap and affordable. So, I kind of fell for that. I don't think you always get what you pay for it. I don't think that saying is always true, but in this case it was, because from day one I had a lot of problems with this SSD, where there was data corruption when it was brand new, and it required a firmware update in order to correct that problem. And it was a lot of hassle to get that firmware update. I actually could not get that firmware update directly from Intel. I was fortunate enough to have encountered somebody on a forum who happened to be an Intel employee, and he worked with me to get the firmware update to fix this problem. So anyway, after that firmware update, it seemed to work okay, but over time, at least in the last 6 months, I was starting to see IO errors. Trying to read old data that was saved on this drive. This was also my boot drive, by the way. So my home directories and my OS boot drive was all on this one SSD. So anyway, I was starting to see some errors. I was kind of expecting it to eventually fail, but I was too busy, too lazy to address it sooner. And then well, it stopped booting, and so now I'm forced to actually have to replace it. And I've already replaced it. I just pulled it out of my laptop. I've reinstalled Fedora Workstation on the new drive. Everything is working. The laptop is working fine. It was just this drive was bad. But I do have some data on this drive, especially in my home directory, that I would like to have. There was nothing critically important, but it just would be nice to have some configuration settings for SSH and my SSH keys and stuff like that. Anyway, so this drive was showing several thousand errors, so it's pretty bad. It wasn't just like, oh, there's one or two bad sectors. It was like, thousands, let's just say. And so today I'm going to try to recover some data off of this drive. And I thought this would be a useful video to show you how I do that, so that in case you ever run into a situation where you have a failed drive that's still somewhat accessible, but you might have a lot of bad sectors, then hopefully this video would help you out. So anyway, the first thing I'm going to do is put it in this USB 3 M.2 adapter. And so this has an onboard controller. This is a NVMe SSD, and this has an onboard controller to convert that NVMe to USB 3. So if you're going to do this, of course, you could always plug this into an M.2 slot on your motherboard or something like that. But for me, I think using the USB 3 adapter is going to be the easiest way to connect it to my workstation. And we're going to try to see if I can recover some data off of this. All right, so before we get started, do me a favor and hit that like button for your YouTube algorithm so more people can benefit from this video. Also, if you're new to this channel and you like this sort of stuff, consider subscribing to the channel and hit that notification bell so you don't miss my next videos. All right, let's get started and install this thing in the M.2 adapter here. And there's this screw. All right. And I think this goes this way. There's another screw over here. Oops. All right, didn't lose it. And this is kind of the reason why I'm putting this all together, even though I'm probably going to take this all apart after we're done here, but don't like losing screws. Now keep in mind, I'm not a data recovery specialist. That's not my specialty, but I have had some professional experience doing this kind of stuff. Professional meaning somebody paid me to do it, and I helped them recover some data. I'm pretty sure that there's going to be data loss, so this is not going to be 100% recovery. There are probably some things I can do to improve the success rate of data recovery with this, because the way the problems are happening on this SSD, it's intermittent. There are thousands of problems. There are thousands of sectors that are here are just bad. But sometimes if you keep trying to read and read and read over again, you can recover some data that previously unsuccessfully read. If I was really serious, or if I was doing this for somebody, a client, and they really wanted all the data or as much data as possible, I would probably do multiple attempts to recover the data off this drive, and then try to merge that data together between the bits that were successfully read off versus previous attempts where it wasn't successfully read, in those certain particular sectors and stuff like that, and then try to merge that data together to get the most complete image of this drive as possible. But like I said, I don't really have a lot of important data on this drive, and so I'm just going to do one attempt, and if I can find basically the essential stuff that I would really like to have off of this thing, I'll call it a day and that'll be done. But anyway, I just want to caveat this with, I'm not a data recovery specialist. I know a few little tricks that have helped me in the past and have helped some of my clients in the past. And so I'm just going to share that with you guys in case it helps you guys out if you're ever in this type of situation. All right, so let's go ahead and get on to the workstation, and I'll show you the next steps. All right, guys, so here I am at my computer, and I have 3 terminal screens in front of you here. So on the very right screen, I have a D message running so that I can see a variety of log messages or kernel messages. And this is useful to have because as you are doing this data recovery and trying to access the drive and stuff like that, you might see some error messages pop up, and being able to monitor that as you're performing those steps is usually pretty helpful in kind of identifying if there's a problem or what's going on if there is a problem and such. And in the middle and left terminal screen here, I basically have a shell with root privileges, and you are going to need root privileges to do a lot of these things. And so I've already kind of escalated those shells to root. All right, so now before we get into the nitty-gritty details of the steps to recover the data off that NVMe drive, I kind of want to give you a bigger picture because there are several steps involved, and I just wanted to kind of show you a bigger picture of the bigger scheme of things are, so that you don't kind of get lost in the details. So along those lines, I've kind of put together this little diagram to kind of show you what's involved in this data recovery attempt. First, you have to kind of understand how the data is organized on your drive, and this is going to be very different for different setups. So if you are running Windows, or you're running a different distribution of Linux, or you've configured a distribution of Linux in a particular way in how it uses those drives, the way your data is organized inside that drive is going to be different, and you need to know that, or at least you need to discover that in order to figure out how to gain access to that data. So this is just an example of how my data is organized on the NVMe drive that I showed you in the previous segment. So over here on the left side of the diagram, here's a picture of the NVMe drive. That's just some generic Samsung drive, but it's not the same exact drive, but it's just a representation of some drive. Okay, we're going to use a tool called DD Rescue to basically pull an image off of that drive. Now, as I said earlier, there are thousands of errors on this drive, and so I don't expect to be able to pull all the data off of this drive, but I'm hoping that I can pull enough data off of this drive to create an image that will become accessible so that I can try to recover some of the data that I need. Again, I don't need all the data on this drive. There's just probably a few files that I would like to be able to recover if possible. None of this is actually really critical to me, but it would just be a convenience if I'm able to pull some of that data off of that drive. And so I'm hoping that by doing this, I'm going to be able to access some of that data and see if it's corrupted or not. And if it's corrupted, well, then, you know, that's just the way it is. And, you know, that's the end of that. But hopefully maybe some of the files I do want to pull out are not the ones that are affected by the thousands of bad sectors on this drive. Once you create a file that is an image of that SSD, the next thing is we need to associate that file to a block device so that we can, you know, treat it as if it was an actual drive plugged in. And so that's the next step here in the diagram, where we're going to use a tool called losetup, which is going to associate or map a loop device to that image file. And so at that point, we're going to have a device called /dev/loop0, and that will basically be representative of that image file, but we can treat it as a block device. Now, if you had a very, very simple setup, this might actually be the only step you really need, other than jumping to the final step, which is to mount the file system and then access your files. But a lot of setups are not that simple. Usually disk drives are partitioned, and then those partitions may also be managed in a more abstract way. So in my case, I'm using LVM, and so it's going to require a few more steps. And that's why I want to kind of show you this picture first, because we're going to be going through all these steps to get to the data, and I don't want you to get lost in the details here. So, all right, so once we've mapped a loop device to that image file, we have partitions within that image file because my drive was partitioned, and I had 3 partitions on this. And so I have partition 1, 2, and 3. 1 is the UEFI partition, 2 was the /boot partition, and then 3 is a partition that I used for both the root file system and my home directory. But this was also managed under a logical volume manager. Okay, so in order to access those partitions, we have to map additional logical block devices to those partitions, and we're going to use a tool called kpartx to do that. Okay, so that's going to give us 3 logical block devices called /dev/loop0 P1, P2, and P3. So now P3, the third partition, like I mentioned earlier, is managed under the logical volume manager, and so I'm not able to access it directly immediately like that. If it was just a simple file system, at this point I could just try to mount that file system, but instead I have to take the additional step of activating the volume group that's detected on that third partition. So once we activate the logical volume group, then we can access the logical volumes within that volume group. And those are /dev/fedora/root, which is the root file system for my OS that was on the laptop, and /dev/fedora/home, which is the logical volume for my home directory on that laptop. And that's really kind of the area where I want to get the most data out of. So that's the general overview of all the steps we're going to take today to get to my data, and hopefully it'll be successful. All right, so let me put this thing away, and let's get back to the recovery process. Okay, so again, on the left side is the D message output, and so we're going to keep an eye on that, and I recommend that as you're watching this video, keep an eye on that, because it'll help you kind of see the things that are happening as we go through these steps. All right, so first thing I'm going to do is I'm going to plug in that USB NVMe adapter that I installed the NVMe drive in. Okay, so you can see already on the right side here, we're seeing a lot of I/O errors, and like I said, there are thousands of errors on this drive, so this is not unexpected. So and this is the problem, we cannot access the data on this drive, and because there's just so many bad sectors, and it's unable to mount the file system. So let's just run. So you can see here from all the error messages that it's referencing SDH, but I'm gonna run lscsi just to confirm. And indeed, SDH shows up as SSK, and I think that's the manufacturer of that adapter, the USB adapter for the NVMe drive. Okay, so we've confirmed that it is SDH. All right, so the first thing we want to do is basically take an image of this drive, and I'm going to use a tool called ddrescue. So ddrescue, And there's a couple options I like to use when I do this. So one is verbose. So that option just gives me more output, and I like to have more information that helps me kind of understand what's going on if there's a problem. So, and the next thing is -B, which is for the block size. Now, if we scroll up here, you're going to notice in one of the messages, it says right here that this drive has 4K physical block sizes. And so I'm going to match that to the block size I'm going to use with DD Rescue. And so that's basically the smallest segment that I can use and trying to recover one sector at a time. Now, this is going to obviously make it a bit slower, but it's the most granular way to kind of try to recover each of those sectors. And the way DD Rescue works is that if it'll try to read a sector, if it doesn't succeed, it will try a couple more times and then eventually give up and move on to the next sector. So anyway, that's what I'm going to do. Now, like I just said, DD Rescue is going to try to read each sector at a time, and we know we have thousands of bad sectors on this drive, and so obviously we're going to encounter some errors. Now, how we handle those errors, I'm going to choose a very particular way that is not the default of how DD Rescue does things. When DD Rescue isn't able to recover and read a particular sector, on the output side, it just basically doesn't write anything. So obviously, since we have thousands of bad sectors, we're going to basically have a file that's several sectors smaller. But because I have partition tables and stuff like that in this drive, I want to kind of maintain the geometry of the image. So I don't want the file to get any smaller than the actual drive itself, the actual hardware itself. And so I'm going to add this option -A, and that means always write. And so what, instead of DD just kind of skipping over, or DD Rescue skipping over sectors that it can't read, it's going to pad on the output side those sectors with zeros. And by doing so, then my final output image is going to be identical in size and geometry to the original hardware. And I'm hoping that this is going to help me maintain the alignment to partitions and stuff like that. And so that's why this is kind of an important thing. And we're probably going to get, you know, a couple thousand bad sectors here. And so there's going to be a lot of padding and stuff like that. But at least it might maintain the geometry of the image enough for me to access some of it. Okay, so then the other option that I would recommend is -L for log. And you can basically specify some sort of log file. So let's say we can call it recovery.log. And basically all the output that we're going to see is going to also be recorded in that log file. And that's going to be useful if you're going to go back and try to identify some of those bad sectors. So I mentioned earlier that the way this NVMe drive is failing right now, it's not black and white. Some bad sectors, when you try to read them, and you can't read them, if you try several times in a row, or maybe try it some other time, unplug the drive, plug the drive in, try it again, sometimes you can read those sectors. If I was really determined to recover as much as possible off of this drive, I would probably get a list of all the bad sectors after this first attempt, and then manually go in and try to read those bad sectors again. And if I can get it, then I can pull that data out and then reinsert it into the padded zeros that I have in my image file, right? So, you know, if there's some really critical data on this drive, that might be what I would attempt to do. But I don't have really critical information on this drive, so that's why I'm not going to do that. But I just wanted to mention that in case you are dealing with a situation where you have really important data and you want to do everything possible to try to recover some of that data. So I would recommend creating a recovery log file so that you can go back and analyze and figure out which sectors are bad, and see and kind of reattempt those on a more granular level to see if you could possibly recover some of that stuff. All right, so anyway, once you specify the log file, we have to specify the actual device. So it's STH in our case. And then finally, the image file that we're going to save all the data we're pulling off of this drive. So I like to call this recoveryimage.bin. All right, so I'm going to go ahead and run this now. And let me kind of just clear a few lines on the right side here, because you're going to see a bunch of errors show up, I'm sure, here. Okay, so now it's attempting to read each of the sectors, and you can see already there's a few errors showing up. Yep, more errors showing up, so there's just a lot of bad sectors on this SSD. I'm hoping that just, you know, it doesn't hit one of the files that I actually want to get out of it. But anyway, this process takes a long time. I've actually already done this imaging process, and it takes about 5 hours. So I'm going to spare you guys the 5 hours, but I just want to show you what it looks like. I'm going to go ahead and do Control-C and kill off this imaging process right now because I already have an image of this SSD that I done prior to recording this video. Okay, so that is located over here. All right, so I have recovery image.bin right here, and if I do that, you can see that it is 477 gigabytes. Okay, and so that's that drive, that NVMe drive is a 512 gigabyte drive. So yeah, so anyway, that's the image file that I took earlier, and you'll notice that I have several copies here. I do recommend, if you're doing this type of stuff seriously and you do have some really important data, that you make a copy of the image file you take and work on the copies and keep the original image file that you've pulled off untouched. And the reason for this is that you can, as you're trying to recover your data, there's a lot of steps along the way that might accidentally alter the image file, and that may or may not damage the data you're trying to recover, but it's always good to work on a copy of the original image so that if you do kind of mess up, then you can just kind of delete the copy and make another copy. Okay, and also don't rely on the fact that you still have the physical drive, the hard, you know, the SSD, because since that thing is failing, it's possible that, you know, if you did accidentally alter the image file in a way that you didn't want, and you want to take another image of that SSD, it is possible that the next time you read that SSD, you might not be able to get all the data off of it, or you might get less data off of it the next time, or it could fail completely and then you're not able to get any data off of it. And so I recommend that you get as much data off of it initially, keep a kind of golden copy of that and don't touch it or don't alter it, and then make a copy of that and work on the copies. I'm going to use recovery image copy1.bin. Okay, so the first step we want to take from this is to associate or map a loop device to that file. So I'm going to do losetup find show, and the show is going to tell us what loop device it maps to that file. And so I'm going to give it the copy1.bin file name. Okay, and so it tells us that it's now mapped /dev/loop0 to that file. And so you'll see this file is now available, and I can actually treat this as if it was the SSD drive itself. So for example, I can probably look at its partition table by using parted. And so you'll see that I do indeed have 3 partitions here. I have the EFI partition on partition number 1. Partition number 2 is ext4, which is was for the /boot partition. And then you'll see partition 3, which is the largest one, is marked with the LVM flag, and that's because that partition was used as part of a logical volume manager. All right, so that's just to kind of show you that you can basically treat this loop 0 device as the SSD itself now. Okay, one thing we do need to do is, let's look at dev mapper for a second. You'll see that I have 2 mapped links already there, fedora-home, fedora-root, and those are my root and my root file system and home file system from that SSD. And that's there because I plugged in the original SSD, and you know, it could detect some of that structure, and so it already kind of automatically mapped that. But remember, the image file, it also has the same structure, so there's going to be some conflict because they're going to have the same volume group name. And so I need to make sure I remove these links first. And so just to kind of confirm for you, if I do a PV display, you'll notice the volume group name Fedora, which is where these 2 links, these 2 mappings come from, is associated to STH3, and that's the physical drive itself. And I need to disassociate that, pull that out, all that stuff, because I'm going to have the same information from the image file, and they're going to conflict. So I'm going to go ahead and do change, deactivate the Fedora volume group. And so now you'll see that those mappings are gone. And I'm going to unplug the USB drive. Okay. So over here, you can see that the USB drive got disconnected, right? All right. So now that we have the image file associated with loop 0, we've removed the conflicting volume group from the original SSD and removed that out of the system. We need to map the partitions on that image file to some logical block devices. So we can do that by kpartx -av dev loop 0. And this is why you want to run the -- show above here, up here, because it's going to show you which loop device it is, and that you're going to need that for this command. All right, so let's go ahead and do that. All right, so you can see that it found 3 partitions and it's mapped them to loop 0 P1, loop 0 P2, loop 0 P3, and we can confirm that here, loop 0 P1 and 1 through 3. And you'll notice that the Fedora home, Fedora root are now back again, and that's because this loop the third partition, loop 0 P3, has that same information, that volume group on it, and Linux detected that and automatically mapped those things. Okay. All right. So at this point, we need to look at the volume manager stuff. Okay. So I'm going to do PV display, and you'll notice this time I still have the same Fedora volume group name, but it's now associated to that loop 0 P3 partition instead of the SDH drive itself, right? So that's why we had to remove that earlier. Okay, now I can activate this volume group. And it says I have 2 logical volumes that have been activated, right? So let's go ahead and do LV display. And you'll see that I have the root file system and the home file system volume groups available now. I'm going to add a few extra lines in here, so because this is kind of getting to the critical point where we're going to mount these file systems, and hopefully this works. All right, so mount read only. So I like to try to mount this stuff without altering it as much as possible, although this is a journaled file system, so it's going to touch the journal. All right, so we're going to mount dev Fedora root. This is the root file system of my laptop drive, and I'm going to just mount it under /mnt, and keep an eye on the right side as I press enter. All right, so you can see that there was some data in the log, in the journal of the file. So this is an XFS file system, and it had to do some recovery. So even though I'm mounting this read only, that journal was used to, kind of fix any inconsistencies in the file system, stuff like that. So it does still, even though you're mounting read only, it still can modify, and does actually modify the image file. And you'll kind of notice that the recovery image copy 1 that I'm working on right now, you'll notice that the date, the last modification date has changed, and that's because of that, what we just did. Okay. All right, so I'm going to now mount the home directory under /mnt/home. Well, actually, you know what? Before we do that, let's take a look at what we have under /mnt, because it did successfully mount that, and there you go. So on the left side here, you can see that we can see the root file system of my laptop from mounting dev Fedora root. And since there should be a home directory here, right? So that home directory currently does not have any data in it, but hopefully if I mount the logical volume for the home directory, this is going to also succeed. And indeed, it looks like it did. So you can see here, it's mounting file system, starting recovery. So again, there was probably some stuff in the journal there that needed to be recovered. So now I can access all my data. Now, again, I'm going to point out that this drive had thousands of errors. In fact, oh, you know what? I should show you guys. I did record a log of when I created this image. So it's right here, recovery image.log. All right, so you can see there's all the warning signs here. There were thousands of these. All right, so you know what, I'm going to go to the very end. All right, so here's the very end, and you can see that there were 2,462 errors in creating this image, and it gives you kind of a little, you know, ASCII art visual of what's going on here. So the X's are where it was able to successfully read the data out, and the dash marks are the gaps where it could not. And so you can see that there are several gaps somewhere, and towards the end it's just really bad. So there were a total of 2,462 errors. So, you know, I'm absolutely expecting that there's a lot of data corruption in this /MNT where I've mounted this image now. So keep that in mind. Looks like I'm going to be able to access that data at least, so I can take a look at it, and you know, hopefully the files that I do care about are not corrupted, and hopefully the corruption just kind of happened to, you know, things that I don't care about, like system files, you know, programs and stuff like that I can reinstall. That's not going to be a big deal, but hopefully it didn't affect like my SSH keys and stuff like that, and some of my settings in my home directory that I want to recover. Anyway, that's how you would recover or try to recover your data from a failed drive. Oh, also, let me kind of step you through on how to undo all this, right? So we have the file system mounted and all that stuff. This is how you undo it. All right, so first of all, we have to unmount the file system, and I'm going to unmount both of them in one command. All right, and you can see, you can confirm that the file system is unmounted on the right. Okay, and we have to deactivate the volume group in this case. So we're going to activate no Fedora. So that deactivates the logical volumes. And so basically it's just going to be stepping backwards, but I just want to show you the steps so you can undo this when you're done. Then we're going to run kpartx, and we're going to disassociate or detach all the mappings. And so that's going to be, yeah, we're on loop 0. All right, so now if you look at dev mapper, you'll see that all the mappings are gone, right? The volume group mappings, the loop 0, P1, P2, P3 are all gone. Okay, and then finally we want to disassociate the loop 0 device with the image file. And so that is just losetup detach dev loop 0. All right, and so at this point, that image file that we were accessing earlier is no longer associated with the loop 0 device, and you know, your system's basically reset back to where it was when we started. All right, guys, that's it for this video. If you like this video, make sure to give it a thumbs up. And if you have a friend who might have had a failed drive and they just never got around to recover the data off of it, forward this video to them to see if it might help them out. Also, if you're new to this channel and you like this sort of stuff, consider subscribing and hit that notification bell so you don't miss any of my videos. Also, if you want to support my channel, go check out my eBay store. I have the best selection of pre-flash IT mode HPA SAS controllers for your TrueNAS, ZFS, or Unraid builds. I'll leave a link down in the video description. Thank you very much for watching, and have a great day. Bye-bye.